Welcome to Physics Prep. This is a question from TATA-GS 2019. In the question, we are told to find the moment of inertia of this shape about this axis. Now, normally in this kind of question, it's pretty simple. First, we find the moment of inertia of the body about the center of mass, that is somewhere here, and then displace this axis to the side so that we can reach the axis that the question mentions. While doing that, what helps us is the parallel axis theorem, which says that the moment of inertia about an axis that is parallel to the axis through the center of mass. This is an axis through the center of mass. This is a parallel axis. So this moment of inertia is from here. This is from here. And we simply add, if this is x, then we simply add mass of the shape times x squared. The cause for concern here is the extra shape that comes about here, and this shape is not really symmetric about the center of mass that we have considered earlier, which means the center of mass should be somewhere here, and it's not easy to solve for it. So what we'll do is we'll forget the axis altogether, and we take this shape as consisting of two shapes. The first one will be something like this. We take this outer sphere, and this has its own axis of rotation. If the moment of inertia of the bigger sphere is IB about the axis and the smaller one is IS, IB equals moment of inertia of a sphere about the center of axis. Let me write it as ICB plus mass of the bigger sphere times x squared. Now what I am doing here is that ICB is the moment of inertia about this axis. So let me write here ICB, and I'm adding x squared. This x is basically the distance from the center of mass to this axis, but this is not actually x, it's r as given in the question, because here this distance is r. This distance from the center to this position is r, and the distance from the center to here is r by 2. R by 2 is the radius of the smaller sphere, and r is the radius of the bigger sphere. So that simplifies our situation. I don't have to write x squared here. In fact, I can write r squared. And similarly, we can write IS equals the moment of inertia about the center of the smaller sphere plus mass of the smaller sphere times r divided by 2 whole squared. And our question simplifies to finding the moment of inertia about the axis, that is IB minus IS. Now, a thing to note here is that we took the same axis in both the cases. That is extremely important here. Now, the moment of inertia of a sphere about the center of mass is equals to 2 by 5 mr squared. Using that moment of inertia, what we get is IB equals 2/5 of mb r squared plus mb r squared, which is equals to 7 by 5 mb r squared. This gives us the moment of inertia of the smaller sphere as 7 by 5 ms r divided by 2 whole square. Now we can do I equals IB minus IS as 7 by 5 mr squared mbr squared minus 7 by 5 ms r by 2 whole squared. This is equals to 7 by 5 r squared mb minus ms divided by 4. Now one thing to note here is that we neither know mb nor do we know ms. The only thing that's given in the question is that the density of the thing is rho. The whole shape has a mass m. The relation between density and mass is given by rho equals to m by v. So what we have to do here is the volume of bigger sphere minus volume of smaller sphere to get the density. So this gives us m divided by volume of bigger sphere will be 4 by 3 pi r cubed. Of the smaller sphere will be 4 by 3 pi r divided by 2 cubed. And on simplifying this, we get 6m divided by 7 pi r cubed. And this is the rho we'll be using, which simplifies the above expression as 7r squared by 5 rho times 4 by 3 pi r cubed minus rho times 4 by 3 pi r divided by 2 cubed, and then again we have 1 by 4 here, which gives us 7r squared divided by 5. Let's put the value of rho after taking out as common, that is 6m divided by 7 pi r cubed, and then the other common things are 4 by 3, we have a pi that's common, and also r cubed. So this gives us 1 minus 1 divided by 4 times 2 cubed. This is equals to 7r squared by 5. So let's cancel off whatever is common in the numerator as well as the denominator. This goes off 7 as well. So this gives us 8r squared by 5 multiplied with 31 divided by 32, which gives us our final solution as 31m r squared divided by 20.